Alright, we just did, where's the pen? There we go. Just did E, we're on F now. We have limit x going to 0 of sine. I don't know what this little box thing here is, but pay no attention to that. It's sine of 2x over sine of 10x. When you plug in 0, you get 0 over 0. Now there's a trick to this one, and it looks like this. We have the limit as x goes to 0. Now remember, we know sine of something over something as that thing goes to 0, x in this case equals 1. So, since we're getting 0 over 0, we're going to try and get that out of here. So here's what I'm going to do. Maybe you like it, maybe you don't. We're going to have sine 2x, and I'm going to rewrite this as two fractions being multiplied, sine of 10x. Okay. Now, the problem with this sine of 2x is I need a 2x on the bottom, so you know what I'm going to do? I'm just going to go ahead and put a 2x on the bottom. No problem. But if I put a 2x on the bottom, I've changed the whole thing. So I need to undo it. So I need to put a 2x on top. Well, check this out. This works out so nicely. I also need a 10x on top of here for this limit to work out. So the x that I put here, I'm going to go ahead and put another x over here. So those x's will cancel. The 2 I'm going to put out here. Now, it's okay for me to put a 2 over there and an x over here. These two things will still cancel out the 2x. Because multiplication doesn't really matter. You can move things around. So this 2 times this times x is the same thing as sine 2x times 2 times x. So it doesn't matter, they're split up. So we're still working right now. We still have the same exact thing we started with. Okay, now I have sine of 10x. I have an x up here. I need what's in here to be the same thing here. And the reason this is going to work is because as x goes to 0, sine x over x equals 1. Well, that's the same thing if you have x over sine x. It's just a reciprocal, and the reciprocal of 1 is 1. That's if x is going to 0. So anyway. So I need a 10 up here, so I'm just going to put a 10 up there. No problem. But now I've changed the problem again. I can't just throw a 10 in there. If I put a 10 on top, I've got to put a 10 on bottom. Well, I'm going to put it out here with this dude. So we have three fractions, really. X is going to 0, 2 over 10, times sine 2x over 2x, times 10x over sine 10x. Well, the sine 2x over 2x becomes a 1. The 10x over sine 10x becomes a 1 as x goes to 0. And 2 over 10 is just 2 over 10. So you really have 2 over 10 times 1, which 2 over 10 is a fifth. There you go. That's your answer. Over here, x is going to 8, x minus 1 over x to the 1/2 minus 1. Well, plug in first, because you could do some work here and cancel things out, but you don't need to. When you plug in 8, you're going to get 8 minus 1 is 7. Over, when you plug in 8, you're going to get the square root of 8 minus 1. Now, maybe you're thinking, oh no, a radical on the bottom. I don't care. Leave it there. Okay? Rationalizing is for, I don't know, sissies. Don't tell your teacher I said that. Oh, hello, wife. What's up?
We need to get going.
Okay, let me finish this. Okay?
How long?
I don't know, like 5 minutes? Alright. You see that, kids? My wife is waiting to go out, and here I am making this stupid video for you. Alright, it's Friday night. I need to be out getting my groove on. Anyway, x is going to 3. We're going to plug it in. We get the square root of, what, 16, which is 4, minus the square root of 16. So that cancels out, and on the bottom we're going to get 9 minus 12 plus 3, so we get 0 over 0. Okay, of course. What we're going to do here is multiply by the conjugate, because we have these square roots. So you should end up with, I can't fit it in over there, but x is going to 3. If you multiply by the conjugate on top, you're going to get both those things squared, which is going to be 13 plus x minus 2x plus 10 over x squared minus 4x plus 3, which is really x minus 3 times x minus 1. That factors, that bottom part of there is factored into that, times the conjugate, because we multiplied the conjugate on top. That's how the square roots went away. I didn't just take them away, multiply by the conjugate. So really we'll multiply the square root plus a square root over the square root plus a square root. I just can't fit it in here. Okay? Okay. So we're going to have the square root of 13 plus x plus the square root of 2x plus 10. Great. Now, look what happens. We have 13 plus x minus 2x. Well, that's negative x. X minus 2x is negative x. And 13 minus 10 is positive 3. So this top, I'm going to write it up here. I'm just all over the place. We're going to have the limit. X is going to 3 of negative x plus 3 over x minus 3 times all this stuff here. I can't really fit it in. I'll write it anyway, whatever. 13 plus x plus square root, I'm going to write over top of this stuff, 2x, bless you, babe, plus 10. There we go. So we got one big fraction. Same thing as this down here, I just simplified it. But negative x plus 3 doesn't cancel with this yet. We need to factor out a negative. So this right here, this top part, I'm going to factor out a negative, and I'm going to get negative x minus 3. Bless you again. And that is going to cancel. Negative x minus 3. So this isn't here anymore. This and this are going to cancel. So we're left with negative over these two square roots. And x is going to 3. So what we're left with is negative 1 over, if x goes to 3, this becomes 13 plus 3, 16. Square root of that is 4. Plus square root of 16, which is 4. And you get negative 1 over 8. I'm squeezing it in here. I don't know how I like this PowerPoint presentation guy. But the answer is negative 1 over 8 for h. Let's continue this charade. Alright. Here we want limit h goes to 0 of this thing, of the difference quotient for it. So we're going to have, let's grab this pen. Let's do a different color. I'm tired of this. Let's do blue. You know I like blue. So we're going to have limit h is going to 0 of 2x plus h squared minus 5x plus h plus 4 minus t of x, which is just that thing. 2x squared minus 5x plus 4. All of that is over h. Now we need to expand this thing here. This is going to get a little big. Let's move it further back here. Limit h is going to 0. We're going to have 2 times x squared plus 2xh plus h squared minus 5x minus 5h plus 4. This is a 5. My handwriting is getting sloppy now. Not that it was really ever great to begin with. Minus 2x squared plus 5x minus 4. All that is over h. Now I'm going to do some quick simplifying here. 2 times x squared is 2x squared. It's going to cancel with minus 2x squared. Let's change colors again. Show this a little bit better. How about orange? Great. So this 2x squared is going to cancel with this 2x squared. He's gone. Then we're going to have minus 5x plus 4 minus 4. So all that's really left, so this x squared is gone too. We're going to have 4xh. Let's write this up top here. Let's do blue. We're going to have limit h going to 0 of 4xh plus 2h squared minus 5h. All of that over h. Now the h's cancel. Bam, 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 bam. Which leaves us with the limit h goes to 0 of what? 4x. Where's the cursor? 4x plus 2h minus 5. And if h goes to 0, the answer is 4x minus 5. There you go. And if you know the shortcut for derivatives, then you can check your answer. 4x minus 5 works nicely. Perfect. Okay. Let's clear all this stuff out of here. Erase everything. Let's go back to red. Why not? Prove that this is continuous at 3. Well, we do three things. This should be easy. First, what's f of 3? Well, you should know this is continuous. It's a parabola. Plug in 3. You get 3 squared is 9 times 2 is 18 minus 4, 14. That's the first thing. Number 2, you check the limit as x goes to 3 of f of x. But since it's continuous, you can just plug it in. Now, again, we're using continuity to prove continuity, but it's just really, you're just checking rules here. That's all you're doing. So, since they're equal, you say that. Limit x goes to 3 of f of x is equal to f of 3. Therefore, it's a little triangle guy. F of x is continuous at x equals 3. Okay, that was 6. Where are we at? 7. How much more do we have to do here? This is forever long. Oh my god. Alright, well, I'm going to have to post this up tomorrow, I think. We'll do these two real quick. My wife's going to yell at me. I hope you're happy. Prove that this is discontinuous at 3. This is easy. Whoa, go back. Where's the pen? You try the first thing. Well, when x equals 3, y is equal to 0 over 0. That's undefined, right? Which is undefined. If it's a limit, you call it indeterminate. But if it's a function, it's just undefined. So, since it's undefined there, you're done. F of x is not continuous or discontinuous, whatever you want to say, at x equals 3. Okay? That was that. Very simple. Nothing crazy, just that's all you gotta do. Cool. 8. Explain why the limit doesn't exist. When you see explain why a limit does not exist, you check the left side, you check the right side. So, limit as x goes to -2 from below means x is approaching -2, but it's less than -2, which means it's on this graph right here, because this is when x is less than -2. And as x moves closer and closer to -2, it moves closer and closer to what this thing equals at -2, which is just, what, 4 times 2 is 8, minus 3 times -2 is 6, 14. There you go. If we do the right-hand limit, x goes to -2 from the right side. Oh my god, we gotta put f of x in here. Man, you can't just do limit with nothing. It's gotta be limit of something. Limit of f of x. So we go from the right side, now we're going to be on this dude because x is greater than -2. Okay? But as x approaches -2, it has to approach what 5x plus 10 is going to equal at -2, and that's 0. Okay? So you write, since the limit as x approaches to -2 from below of f of x does not equal the limit as x goes to -2 from above f of x, the limit does not exist. So you can write this out. The limit does not exist. D and D. You should probably write that out in words on a test or something, but whatever. There you go. That's 8. I'll try and finish these up and post it up tomorrow. Okay.